Hello, beautifuls. This is Atleen, and I'm coming to you with another YouTube video. So today we will be discussing common fiber connectors, and the common fiber connectors is listed in a diagram. First, we have fiber optic connectors, subtitle single fiber connector, multi-fiber connector, and under the multi-fiber connector, we have duplex only, 2 fibers, MTRJ, which is what we will discuss today, VF45 and others. And then we have ribbon fiber connector, which is underneath that is MT/MPO. Single fiber connector, and we have 2.5 mm ferrule. ST, SC, FC, which we will discuss today. 1.25 mm ferrule. LC, which we will discuss in brief today. MU E2000. And I will be reading out of CCNA 200-301, Wendell Odom. In this diagram, we will discuss 2.5 mm ferrule connector, which is ST, SC, and FC. ST, SC, and FC. And it's not on this screen, which I will go to the next slide. LC is also very common. The 3 most common connectors include SC, ST, and LC. Most popular today is these 3. Also known as Sam's Charlie, how you could memorize it. Sam's Charlie, Sam Tom, and LC is on the next page, but it's lucid. So note SC, simplex, single mode, multi-mode, duplex, single, multi-mode. And there is a latching connector with a bot and ceramic ferrule. All connectors are somewhat the same. There is a push and pull style connector. The FC is a threaded. The FC is a threaded connector, VI Frank Charlie. So we're looking at LC as well. 1.25 mm ferrule connector. Discussing LC, simplex mode, duplex, single mode, multi-mode. When we connect our filter into our devices, note that we always have 2 connectors. One will be useful for transmission and the other for receptions, and these are called ST connectors, also known as bayonet connectors, but the other end is an MTRJ, and both of the strands of fiber come out on a tinier connector, and this will give us a lot less footprint as we are doing cross connects for the different fiber while plugging things in to the wiring closet. There is the lucid connector. We can push down on it. LC, and we can push down and snap it in. And there's the SC, also known as the square. also known as the square connector, SC, square connector, where you just push this one in directly and it snaps. To get it out, it's just spring loaded. You can just snap it in and snap it out. Now this one right here is also a fiber connector. And there may be an issue. You see this part right here? There may be an issue that we may need to avoid as seen in this diagram. And it's called ultra physical contact, UPC. And this occurs when our connection to two strands of fibers together and aren't angled at 8 degrees. Then it needs to be cut at an angle because as you can see, it's straight. This is a straight. And I'll go to my notepad where I have all my notes. As you can see, these are straight. Where you push in this barrel and we twist it and it should lock in. And put the other one in the other side of the barrel and it should lock in as well. So ideally, the barrel would be holding these two tips right next to each other, where light should go right into one fiber from the other. But since we are dealing with light, these tips, no matter how well polished, they'll never fit perfectly because they're flat. It's flat, okay? So the goal is to get it at an angle. So that results in reflection, which isn't good if it's too flat together. That results in reflection, which isn't good because the light, sometimes powerful laser light, that's an example, reflects back to the sender and it may damage that sender equipment. So to overcome this, we use angle physical contact, APC. And that's where you cut the wire at an 8-degree angle. This is an example. Fiber connector. And this is where we cut the angle. It's at an angle, 8-degree angle. And that's the goal. So now I will read from CCNA 200-301, Wendell Odom. And we will discuss breaking down a UTP Ethernet link. So I will read. The term Ethernet link refers to any physical cable between two Ethernet nodes. To learn about how a UTP Ethernet link works, it helps to break down the physical link into those basic pieces, as shown in figure 2-6. This is 2-6. Basic components of Ethernet link. The cable itself, the connectors on the ends of the cable, and the matching ports on devices into which the connectors will be inserted. Cable with wires inside. First, think about the UTP cable itself. The cable holds some copper wires grouped as twisted pairs, even though on here it doesn't say twisted pair, but this is a twisted pair. The 10 base T and 100 base T standards require 2 pairs of wires, while the 100 base T standard requires 4 pairs. Each wire has a color-coded plastic coating with the wires in a pair having a color scheme. For example, for the blue wire pair, one wire's coated is all blue, while the other wire's coating is blue and white striped. Many Ethernet UTP cables using Rj45. This is Rj45. Rj45. The Rj45 connector has 8 physical locations into which the 8 wires in the cable can be inserted, called pin positions or simply pins. These pins create where the ends of the copper wires can touch the electronics inside the node at the end of the copper wires, at the end of the physical link, so that electricity can flow. Electricity is copper. With fiber, it is light. Note, if available, find a nearby Ethernet UTP cable. Examine the connectors closely. Look for the pin positions and the colors of the wires in the connector. To complete the physical link, the nodes each need an Rj45 Ethernet port that matches the Rj45 connectors on the cable, so that the connectors on the end of the cable can connect to each node. PCs often include this Rj45 Ethernet port as part of a network interface card, NIC, aka NIC, which can be an expansion card on the PC or can be built in the system itself. As you can see, the Rj45 Pin Out is T-568B, as discussed in the CCNA 200-301 Wendell Odom book. They are color-coded, and the pinouts are 1 through 8. 1 is white-orange, 2 is orange, 3 is white-green, 4 is blue, 5 is white-blue, 6 is green, 7 is white-brown, 8 is white-brown, as you can see. As you can see, it's 8 slots for the pinouts right here. 1, 2, 3, 4, 5, 6, 7, 8. And this is the twisted pairs right here. All right, so now I will go to, do I know this already? And the number that we're going to discuss, that we did discuss today, is going to be number 5. Which of the following are advantages of using multi-mode fiber for an Ethernet link? It's A, B, C, or D. B, to extend the link beyond 100 meters while keeping initial cost as low as possible. Thank you for watching. Thank you for subscribing. Please keep reading, keep going, and I wish you luck.